Okay, exam 1, Friday or Monday in recitation. Come 15 minutes early. It will cover everything through today's lecture, okay, from the first day of class to today. It won't cover Friday stuff, but the things we do on Friday will use a lot of principles, so there's good things to think about for your exam. But specifically, the content on Friday is not covered. All right, so you got the exam prep area at the left here for really helpful resources. I'll show you that in a second. Don't forget the Pathways Tutor Room. Okay, so these are your best chance for help on all of campus. Okay, if you go to other tutoring, other math tutors, they won't be as helpful as this. It's not perfect, but this is your best. After myself and Jerome, these are the best people to help you. Okay, open Monday through Friday, starting at 9. On Fridays, it closes at 1. Okay, take advantage of the tutor room. All right, so exam prep. Exam 1. So the first thing is a comprehensive bullet list of what's covered on the exam. Second thing is quizzes 1 through 3. So far I have blank versions and solutions for 1 and 2, and just the blank version for number 3. We'll get the solutions up later on today, maybe tonight. So that's the quiz area. And then some sample exam items. This is not comprehensive. This is all. It all pertains to the material we've covered, but it's not comprehensive of the material. It's just to give you a feel for what the exam is like, give you a little practice. And answers versions will come up tomorrow night at 7. Okay, so try to work on it before the answers come up, or if it's already after 7, don't look at the answers. Really try to work on it like it's the exam. Then once you've exhausted all your ability to do it, then look at the answers. And then at the end of class, we're going to start this inverse and composition practice worksheet, which you can keep working on for studying. There's nothing to submit for that, but it's good practice of these last few lectures. Okay, so all that stuff is to help you study for the exam. Any questions about exam or preparation? Should cover it. But do you have any questions? Okay.
So it's going to be in the PSA 21?
What's that?
It's going to be in the PSA 21 room?
No, it's in recitation.
Oh, it's in recitation.
Come 15 minutes early to recitation. It's in recitation. Okay, let's get started. So, all right, so on, I don't know what page this is in your investigation 5 in the workbook, there's this thing about Celsius and Fahrenheit. When someone finds that, tell me what page that's on. 102. Page 102. Page 102. I'm going to be using this context, but it's going to stray it's not going to stay with the questions they're asking. So you do want to take notes, but we're not going to be going through and answering those questions. Exactly. Okay, so the first thing is, it doesn't work. They introduce this function, and they say g of c is 9/5 c plus 32. And they say it converts, this function converts degrees Celsius to degrees Fahrenheit. Okay, so if this function converts degrees Celsius to degrees Fahrenheit, what is the input of this function? A function that converts Celsius degrees to Fahrenheit degrees. The input will be Celsius. Okay? If you talk about a function in terms of converting something, it's going to start with something. In that case, that'll be the input, Celsius. It'll convert it to Fahrenheit, so the output is Fahrenheit degrees. Okay, what is the name of this function? Inverse, what's that? What's the name of this function? We also know this. G, no, not GFC. G. G is the name. It represents this relationship of converting temperature, right? G is the name. What's the input?
C.
C. What's the rule? Everything on the right side of the equal sign is the rule. Okay, so what would this mean right here? What I just wrote, that expression, tell the person next to you what exactly, precisely what that means. What I just wrote, G of 100. Go. What does that mean? I should hear 40 conversations. It's not about plugging anything in. It means something. G of 100 means something. What does it mean? It's not about plugging something in. So this is not telling you to plug in 100. We can't. We worked on that when we first introduced the notation. It means something. What does it mean? What's that? Right? The output of the function when the input is 100. It's the output of the function when the input is 100. So now talk to me about someone else. Say that same thing. Talk to me about temperature. So it's the same exact thing. What does it mean? But now talk to me in context. Matt.
So basically, when the input is 100 degrees Celsius,
Okay.
your output will be the input of.
But what is that? So you're telling me, yeah, but what is that? G of 100? Degrees Fahrenheit. You see? So yeah, so all that stuff you're saying is correct, but that thing is degrees Fahrenheit. Which degrees Fahrenheit is it? Any? When Celsius is 100. When Celsius is 100. So it's the output when the input is 100, or it's the degrees Fahrenheit when it's 100 degrees Celsius. Okay? And if we want to know what that is, then we use the rule. And we get, if you plug in 100 for C, you get 212. Okay? All right, so what if we, so here's that same thing again. What if we wanted, so F equals 9/5 C plus 32. And this is our G of C function. And so what is the process that it says, let's write down, what is the process that it says to do to Celsius to get Fahrenheit? So you take this input of Celsius, and what do you do first to get Fahrenheit? Multiply by 9/5. And then what do you do next? Add 32 to that. And you get Fahrenheit, right? You get Fahrenheit. So what if we wanted to step this back, okay? I've got Fahrenheit, and I want to know Celsius. So wouldn't I just walk this backwards this way? So if I had Fahrenheit, what would I do first? If I'm walking this backwards, I take Fahrenheit, I do what?
Minus 32.
Minus 32. And then what do I do with that? Divide by 9/5, right? We're going to march this back in reverse. The first thing we would do with Fahrenheit is we'd subtract 32. And then the next thing we do is divide by 9/5. So divide result by 9/5. And we'd end up with, what would we have? We'd have Celsius, right? So let's write a new function called h of f. based on that set of instructions that we just made. So h of f, what do we do first to f? I've got f. First thing I'm going to do to it, subtract 32. Then, divide that result, take that whole thing, divide it by 9/5. So we just created a function that does the reverse process, that undoes what we did before. This one, what is its input? What is the input of h? Degrees Fahrenheit. We stepped back the process of the g function, and so it will give us output Celsius. Okay, so just by walking back the g function, writing down what it does, and then creating a mathematical equivalent of that, we created a new function that takes the Fahrenheit degrees and gives you Celsius degrees. Okay, does it make sense? So we're talking about, given one function, can we create another function, or is there another function that reverses the process, or kind of undoes what that first one did? All right, and so that's what we call an inverse function. Inverse function. Okay, so what if I were to all right, so what if I were to take G of C? What does that represent? What does that give? Fahrenheit if Celsius is C. Okay, so that'll give Fahrenheit. Well, since that's a Fahrenheit degrees, is it valid to put it into H? Is that okay? Does H like that? Yeah, because the input into H is Fahrenheit degrees. So the output of G is Fahrenheit, so is the input of H. So what's this process here? We're going to take Celsius, and G is going to convert it to Fahrenheit. And then H is going to take Fahrenheit and do what? So if this were, say, 80 degrees Celsius, and we put it through this process, what would end up happening? We get 80. We get whatever we started with, right? Because G is going to convert Celsius to Fahrenheit, then H is going to convert it right back to this what we started with, which was C. So let's show that mathematically. Let's show that that's true mathematically. How can we do that? H of G of C is the same as, so we're going to prove it. All right, H of, what is G of C? What is G of C? The same as. Did some homework like this, right? 9/5 C plus 32. That's what G of C is, 9/5 C. And now we're putting an input into H. We're going to look at what H says to do, and we're going to do whatever H says to do, we're going to do it to that input. So what does this equal? What does if the input into H is 9/5 C plus 32, then what would that equal? Yeah, Adam. 9/5 C plus 32. Okay, so there's that whole thing. You said all that, what? Minus 32. All right, did you see what he did? He applied the rule for H. He applied the rule for H for the new input, 9/5 C plus 32. What does H say? It says take the input and subtract 32. Take the input and subtract 32, and then divide by 9/5. Well, the input was 9/5 C plus 32. So we took that input, subtracted 32, and divided by 9/5. Does it make sense? So this should be review, right? You were doing this for homework, and we did it on Wednesday. Okay, so now we finish it out. What can we do? 9/5 C plus 32 minus 32. What is that? 9/5 C. 32 minus 32 is 0. So we got 9/5 C. then that's the numerator, over 9/5 equals. It worked. That's what we thought, right? We thought if you put a degree Celsius into G and then take that result and put it into H, you should get back what you started with. And we just proved it. Okay? So now you're going to do it down here. So what is the input into G? In general, what kind of thing is the input into G? Please know that. What kind of thing in general is the input into G? What quantity? Hello, Earth to class. Celsius, degrees Celsius, right? That was the first function we looked at. So would it be fair to put in H of something into that? Does it work? Will it accept it? Will G accept that? Because the output of H is degrees Celsius. It's okay. Output of H is degrees Celsius, and that's what G accepts. Okay, so if we take a Fahrenheit temperature, put it into the H function, we'll get some Celsius temperature. If we put that into G, what will we get? The original Fahrenheit we started with. Should make sense. H converts from Celsius to Fahrenheit. No. H converts from Fahrenheit to Celsius and then takes that output of Celsius. G converts it back to Fahrenheit. So you're going to do what we did up here. Prove it. Show the math that proves that. You're going to do it now. Show the math that proves that statement. Jerome can help you. Person next to you, you can work together. Prove that G of H of F equals F. Oh, tell me what you did. Yeah.
I plugged in F minus 32 divided by 9 into C for the equation F.
Okay, so tell me what you wrote.
So I have G of H of F equals
So what did you put in for G?
F minus 32 divided by 9/5.
Here's his first step. What do you guys think? He took the rule for H, which is the output of H, and plugged it into G. Is it right? Okay, go. Keep going.
So I have 9/5 times the quantity F minus 32 divided by 9/5.
Mm-hmm.
And plus 32 outside of the quantity.
Was that outside?
Yeah.
What do we think? Okay. Take over from there, Walter.
Then you're left with the Celsius.
We got to do the math here. So how do we, and we're not going to be left with Celsius, right? We got to do the math.
Yeah, so you multiplying 9/5, and then that crosses out.
9/5 divided by 9/5 is 1.
Yeah.
So we get?
Yep. And then negative 32 plus 32 is 0. So you're left with that.
That's what your proof should look like. That's what it should look like if you got it right. Okay, so this is showing mathematically if you have one function that's the inverse of the other, right? And you put it through, you start and you go through one process, And then you put it through the process that undoes that or reverses it, then you're going to get back what you started with. So that this is mathematical proof of that. Okay? Any questions? Okay, so this is the idea of inverse functions. We started with g of c was 9/5 c plus 32. And so here's the notation. This is not an exponent. That does not mean to the negative 1. It does not mean 1 divided by g of f. It's the notation that we use for inverse. So this notation means the inverse function. So it's not the greatest notation. Why? Because you might think it's to the negative 1 or 1 divided by g. That's not what it is. It means an inverse function. Okay? And so if the input of g was c and its output was f, then the input into g inverse will be f and its output will be c. Okay, so lots of times though, you'll just see x being the symbol, the generic placeholder for input, right? So that's what we're used to. So what would g of x be? How would you write the rule if it was g of x? Go, Eric. What would it be if it was x?
G of X. So you just replace,
Tell me.
instead of using the F, we use X. Is that what you're asking?
Yeah, so this is the input, right? And this tells us what to do with that input c. So what would g of x be?
G of X would be 9 this X plus 32.
Right. Okay? So then we could talk about the inverse function, but again, generically use the symbol x, because that's what lots of textbooks do. You'll see this in the real world, that just use x. And so g inverse x would be, Nicholas. Nope. That's exactly what it isn't, right? So it doesn't mean raise it to the negative 1.
Would be inverse of 9 this. So it would be 5 9.
But it's defined right here, right? It's defined, that function is defined right here, Danny.
5 9 x minus 32.
Right. So what does x represent in this first line? X means what? What is the meaning of x in that first line? Degrees Celsius. So we need to know that the g function takes Celsius, converts it to Fahrenheit. What is the x in the second one? Degrees Fahrenheit. So x takes on a different meaning if we write both of those out like that, because in the inverse function, that input will be Fahrenheit and the output will be Celsius. So x is Celsius. X is Fahrenheit. So you really have to know what the function does, what the quantities are for input and output. Make sense? Okay. So remember, just as a reminder, we say f inverse. It's not 1 over f. It's not an exponent, negative 1. It means the inverse function. Okay, so let's explore this. Let's look at some perspectives and properties here. Okay, so one way to think of the inverse is the reverse process. Okay, so if this is our process f, it takes input, it cranks on input and spits out output, then the reverse process is like the same machine, but we're running it backwards. So therefore, the output of f is the same as the input of f inverse. If we're going to run it backwards, whatever the output of f would be is like the same quantity as the input of f inverse. And then what about the input of f? Output of f inverse. Okay, so the output of f is the same quantity as the input of f inverse. And the output of f inverse is the same quantity as the input of f. So thinking of the inverse as the same machine, but you're cranking backwards now. It's cranking backwards. So input and output are swapped. Make sense? Okay, so in this expression right here, we want to identify 4 things. So in that right there, f of x, where do we see the input of f, the output of f, the input of f inverse, and the output of f inverse? All 4 of those things show up there somehow. Okay, so we want to identify that. Each one. Okay, so where do we see? Oops, go back, sorry. I got click happy. Here we go. So where do we see the input of f? Where's the input of f? X. Where do we see the output of f? F of x. The whole thing represents the output of f when the input is x. Okay, so then where do we see the output, or the input? Where do we see the input of f inverse? Where in that expression do we see the input of f inverse? The whole thing, right? The whole thing will be like an input into f inverse. So it's in disguise, like it's not overtly there, but because we're looking at something about the function f, but kind of implied is that that whole thing also represents the input of f inverse. And where do we see the output of f inverse? Right. Sorry, guys. That time I hit the wrong button. So I want you to do the same thing for f inverse of x. Okay, so now identify all 4 of those things. Input of f, output of f, input of f inverse, output of f inverse. Go. It won't take long. Okay, Lexi, you're up. Tell me. How about the input into f? Where do you see in this expression the input into f? She wants the whole thing. Is that right? Right. The quantity that's the input into f would be represented by the whole thing, which is also the output of f inverse. Okay. Where do we see the so the output of f? Where do we see the output of f here? X. Why? Because that's the input of f inverse, so it's the same quantity as the output of f. And where do we see the output of f inverse? I kind of lost track of what I've asked you and what I didn't. Which one didn't I ask you? Okay, I think, do we get it? All right, so here's some from your book. Somewhere close by in your investigations, you have this table. What page is this on? Page what? 103. Page 103. So the reason that I emphasize being able to see those things and that last little activity that we did was to solve problems like this. You have to know that and identify input and output of f and f inverse in order to correctly evaluate these expressions. So you have this table. X is the input into f and g, and then the second and third column are output values. Okay, so that's the output of f and output of g when the input is x. So now you have to interpret this through all these, knowing what we know about f and g, figure these things out that are mostly about f inverse and g inverse. Okay, So correctly identify input and output, use the table, and solve these. And I'll keep taking roll. Go. See how it goes. Let's just do the first one together. So g inverse 3, how does that relate to the function g? What is that going to be? The function g. It's not the output of g. That's why we practice it. This is the input of g. Three is what? Output of g. Do you understand? Everything's flipped when you have inverse. So this is asking for the input of g when the output of g is 3. What is that? Negative 1. You're going to look at an output of g of 3, which is here. What's the corresponding input? Negative 1. So this thing equals negative 1. Get it? Okay, go. Work on this. So what is g of 0? The output of g when its input is 0, 2. So now 2 becomes the input of f. So that's going to be an x value. We're going to get 6. See a 6. Does it make sense? Okay. F inverse of 6. I'm not asking for a number, but what thing is that? How do we describe that? F inverse of 6. Okay, the output of F inverse is the same as the input of F. So 6 then would be what relative to F? Output of F. So we're looking at the input of F when you get an output of 6. So we're going to look in which column? It's for 6. F. And we're going to get the input of 2. So now what is 2 relative to G? If it's the input into G inverse, then it must be the output of G, and it's asking for the input of G when the output of G is 2. It's a little confusing, but you just got to keep your wits about you. All right, so output, this could be the output of G, so we're going to look here. 2, corresponding input, 0. So this whole thing equals 0. Is it better? Okay, let's move on. That's important that you can do that. Okay, another way, so there's the inverse reverses, but then the inverse also undoes. Okay, undoes. So if we have one function f that takes an input of x, it gives f of x. So another way to think of it is instead of reversing the same machine, it's a new machine. It's a new machine that undoes what that one did. So we're going to take f of x and put it into the f inverse machine. It's going to undo what f did. And what will the result be? X. Okay, so now I want you to write function notation. So can you represent in function notation this whole picture? Can you represent with function notation this whole picture? If you can do that, you're doing really good. See if you can do that. Use function notation, for instance. H of a plus 20. That's representing, using function notation, that's representing the output of h when the input is a plus 20. Okay? So something like that. You're doing some kind of expression, function notation, that describes that whole picture. See if you can do it. If you can do this, you're getting it. Any volunteer? So I'll just take a volunteer for this. Matt thinks he's got it.
F inverse f of x.
Okay? She says f inverse f of x. What are you going to say? Okay, so they basically said the same thing. Adam just Finished it out. He said f inverse of f of x equals x. Is that what that picture shows? What function comes first in this? F comes first, and we take the output of f and we put it into f inverse. We take the output of f right here. We put it as the input into f inverse, and the result is? He nailed it. Is that what you wrote? If you wrote that, that means you're getting it. This function notation stuff is making sense. But that expression is the same thing as that picture. That expression is the same thing as that picture. Okay? But if f inverse undoes the process of f, all right, so we got that. If f inverse undoes the process of f, then, okay, watch this. Whoa. Then f also undoes the process of f inverse. So if you performed f inverse first, then f would undo that. Okay? So use function notation to represent this. This should be easy now. You got it. As an example. So what would the function notation be to represent this? Okay, is it Zan? Is that right? Zan. What would it be? Did you get it? No? Next to him. What's your name? What is it? Christian. What'd you say? You didn't get it? Nicholas, right behind him. Uh-huh. F inverse of x equals x. That's what this picture shows. That we put something into f inverse, we take that result, we put it into f, we get back what we started with. Okay, so let's look at that worksheet. Oh, no, so we got something else. Where's the notes thing? Slide 65. Okay, so check this out. This function is for the volume of a sphere. Input is the radius, and the output gives you the volume of the sphere. Dang it. We'll just leave it. Okay, so if we had f of x, I'm scared. Okay, f of x would be 4/3 pi x cubed, and x is what the input quantity x represents, radius. Output of f would give volume of the sphere. Okay, so let's do what we did earlier. What is the set of instructions that this function says to do? Take the input and do what? What first? Cube the input. And then after you cube the input, what does it tell you to do next? Multiply by? So we can just take that whole thing together. 4 pi over 3. Or 4/3 pi, either way. So if we want to write the inverse function, again, we're going to just start with what quantity? What quantity would we start with? Be a volume, right? So that when we take the radius and cube it and multiply by 4/3 pi, we get volume. So if we're gonna write the the function that undoes this, what's the first thing we'll do with volume? Divide by 4/3 pi. And then cube root that result. That's right. So now, based on that set of instructions that undoes f, we're going to write f inverse. So what would f inverse be? F inverse of x. First of all, what's the quantity x represent in f inverse? Volume. Now x means volume in this function. So we're going to take x. What are we going to do first? Nope. We're going to divide by 4/3 pi. And then cube root that result. There's the inverse function. That's it, if we did everything right. So we just walked back, we wrote the process that would undo that given process, and we get that function then would take volume and give corresponding radius. So I want you to practice this. I think, any questions before I erase that? Did that make sense? This one, E, part E, and what page is that on? Page 104. F of x is 2x minus 5 all over 6. Here's what I want you to do. I want you to write out the steps with phrases of what this says to do to the input to get to the output. Okay, you're going to have 3 steps this time. There'll be 3 steps. You're going to write those steps out long, right, with English phrases. Then write out the English phrases that would undo that process, and then write the rule. Okay, so quick. F does what first? Multiply input by 2. Take that result and subtract 5. Then divide by 6. Reverse in reverse. Multiply by 6. Add 5. Divide by. This is cool, isn't it? You guys have done this before in algebra or something. This is kind of new. Divide by 2. So now we're going to take the input and do what? 6x plus 5. See how cool that is? Okay, so what we'll do is we'll start class with some of the stuff on that worksheet. But that worksheet is covered on the exam. So you're ready to start working on it. We'll review some of it at the beginning of class Friday. There is web work due Friday for inverse, and it's on the exam. Okay? Yeah.
Is that worksheet on?
It's in the exam prep.
Oh.